When you've spent enough time inspecting mature trees, you eventually encounter a structural situation that raises an important question. Can this tree be preserved safely with support, or is failure inevitable? Large trees with heavy limbs, codominant stems, or structural defects often need assistance to remain safe in the landscape. For arborists, understanding support systems is critical, not just for tree preservation, but for risk mitigation and long-term tree management. This podcast focuses on the systems arborists use to support and protect trees from structural failure. We'll explore cabling, bracing, guying, grounding, and the hardware used to install these systems safely and effectively. And for those preparing for the BCMA exam, this topic regularly appears in questions involving structural defects, hardware selection, and installation methods. Let's dig in. When arborists talk about structural support in trees, the most common practice is cabling. Cabling involves installing a cable between branches or stems to reduce the risk of structural failure. The goal is not to rigidly lock the tree in place. Instead, it's to redistribute load and limit excessive movement during storms or heavy winds. The material most often used for these systems is wire rope. Wire rope is constructed from multiple steel wires twisted together into strands. These strands are then twisted together to form the final rope structure. One common configuration used in arboriculture is a 7-strand cable. This design balances flexibility with strength, making it suitable for tree support systems. Another term arborists frequently encounter is aircraft cable. Aircraft cable refers to high-quality wire rope designed for high strength and flexibility. It is often used in tree cabling because of its reliability. Within this category, different strength ratings exist. A common material used historically is common-grade cable. However, many modern installations use extra high-strength cable, often abbreviated as EHS cable, which provides greater strength and durability for large structural loads. Now, a cable system can be installed in different ways, depending on the structural problem being addressed. One of the most widely used approaches is the direct cable system. In this setup, the cable is attached directly between two stems or branches that require support. Another approach is the box cable system. This system forms a supportive box pattern connecting multiple stems. It is often used when several codominant stems share a common attachment point. Codominant branches or stems are one of the most frequent reasons arborists install support systems. These stems grow side by side and often develop included bark between them. Included bark occurs when bark becomes trapped between two growing stems, instead of forming a strong branch union. Over time, this creates a structural weakness that may split under load. Cabling helps reduce the likelihood of that failure. Now here's an important distinction that often shows up on certification exams. There are two primary types of cabling systems: static cable systems and dynamic cable systems. A static cable system is rigid. The cable is installed taut and limits movement between the supported stems. Dynamic cable systems, on the other hand, allow controlled movement. They are designed to absorb shock loads and permit natural tree motion while still providing support. Understanding the difference between static and dynamic systems is essential when selecting hardware and materials. Installing a cable system requires secure attachment to the tree. This is where anchor hardware becomes important. Anchor hardware refers to the hardware installed in the tree that supports the cable connection. Several types of hardware are used depending on the installation method. One option is the eyebolt. An eyebolt passes completely through the branch or stem and is secured with a nut on the opposite side. Because it penetrates the entire branch, this installation is often referred to as through hardware. Another option is a lag eye. A lag eye uses lag-threaded hardware that screws into the wood rather than passing all the way through. Similarly, a lag hook, sometimes called a J-hook, also uses lag-threaded installation. These are sometimes used when full through hardware installation isn't feasible. Machine-threaded hardware refers to bolts that use standard machine threads and nuts to secure the connection. The bolt itself is one of the most fundamental pieces of support hardware. To install these bolts properly, arborists typically use specialized drill bits. A ship auger or auger bit is commonly used to drill clean holes through branches or stems. Once the anchor point is installed, the cable must be secured properly. This brings us to termination. Termination refers to the end connection of a cable system, where the cable is secured to the hardware. Several termination hardware options exist. One of the most widely used components is the thimble. A thimble protects the cable where it bends around the hardware, maintaining an appropriate bend radius and preventing abrasion. Maintaining proper bend radius is important because tight bends weaken the cable and reduce its strength. The cable is typically secured using a cable clamp or wire rope clamp. These clamps compress the cable against itself to hold it in place. Another termination option is the swage sleeve. A swage sleeve is compressed onto the cable using specialized tools, creating a permanent connection. Crimp-type connectors function in a similar way. They require a tool to crimp the connector tightly onto the cable. In contrast, clamp-type connectors rely on mechanical compression rather than crimping. Another important component is the cable stop. This small fitting prevents the cable from slipping through certain hardware assemblies. Some arborists also use eye-splice techniques to create loops in the cable without hardware connectors. An eye-splice weaves the strands of the cable back into itself to form a secure loop. In modern arboriculture, pre-manufactured systems are also used. A preformed tree grip, sometimes simply called a tree grip or dead-end grip, is a pre-engineered cable termination that wraps around the cable and hardware to secure the connection. These devices are sometimes referred to as dead-end grips or dead-end hardware because they secure the end of the cable. Tools also play an important role during installation. When tensioning cable systems, arborists may use devices such as a come-along to apply pulling force. This tool provides mechanical advantage, allowing the arborist to tighten the cable safely and precisely. Gripping tools like a Chicago grip or Haven grip can temporarily hold wire rope during installation. Another tool sometimes used is a cable grip, which helps pull cable through hardware during installation. In some cases, arborists use cable splicer tools or cable aid devices to assist in cable handling and assembly. During installation, the cable should be tightened until it is appropriately taut, but not excessively tight. The goal is to provide support without over-restricting natural tree movement. Now let's shift from cabling to another support method, bracing. Bracing is used when structural movement between stems must be minimized. Instead of flexible support like cables, bracing involves installing rigid rods directly through weak unions. A bracing rod, also called a rigid brace, passes through both stems of a weak union and secures them together. These rods are often made from threaded rod material. The threaded rod passes through the tree and is secured with washers and nuts. A specific type of bracing configuration is the dead-end brace, which helps resist splitting forces at a weak union. When installing these rods, arborists often peen the ends of the threaded rod. Peening involves slightly deforming the metal threads to prevent nuts from loosening over time. Another situation arborists encounter involves trees that need external support rather than internal reinforcement. This is where guying comes in. Guying uses a guy, which is a cable or line attached from the tree to an anchor in the ground. Guying is most commonly used with newly transplanted trees that need temporary stabilization. The anchor used for guying may include ground hardware, such as a ground rod, ground plate, or ground terminal. A ground terminal is also referred to as a grounding electrode. These anchors hold the support cables in the soil. In some cases, anchor hardware includes specialized connectors such as an almond eye nut or connector clamp that secure the cable to anchor points. Now here's where arboriculture overlaps with electrical safety. Tall trees can interact with lightning. To reduce lightning damage, trees may be equipped with lightning protection systems. These systems include a conductor that runs from the top of the tree down to the ground. At the top of the system is the air terminal, which is designed to intercept lightning strikes. The electrical current then travels through the conductor to the ground. A bonding conductor may connect multiple metal components of the system to ensure proper electrical continuity. The current ultimately reaches the ground rod, ground plate, or other grounding electrode embedded in the soil. When installed properly, the system safely transfers electrical energy to the ground. Without proper grounding, lightning may travel unpredictably through the tree, causing structural damage. This can lead to phenomena like side flash, where lightning jumps from the tree to nearby objects. Another potential hazard is step potential. Step potential occurs when electrical current spreads through the soil after a strike, creating voltage differences between points on the ground. That's why grounding systems must be properly designed and installed. Now let's talk about how arborists recognize when support systems are necessary. Imagine you're inspecting a mature oak in a public park. Two large codominant stems rise from the same union. As you look closely, you notice included bark deep within the attachment. You also observe slight separation between the stems. This is a classic candidate for structural support. A combination of cabling and possibly bracing may reduce the likelihood of catastrophic failure. Or imagine a newly transplanted tree, struggling to stay upright in loose soil. Guying with properly installed anchor hardware can stabilize the tree until the root system establishes. These are real decisions arborists make every day, and understanding these systems allows you to preserve valuable trees while reducing risk. Before we wrap up, let's reinforce the key ideas from this chapter. Tree support systems rely on a combination of cabling, bracing, and guying. Cables made from wire rope, including aircraft cable, common grade cable, or extra high-strength cable, provide flexible structural support. Cabling systems may be static or dynamic and installed using direct cable systems or box cable systems. Proper installation depends on hardware such as eyebolts, lag eyes, lag hooks, thimbles, cable clamps, swage sleeves, and termination hardware. Bracing rods made from threaded rod provide rigid reinforcement for weak unions. Guying systems stabilize trees using ground anchors like ground rods or ground plates. And lightning protection systems use air terminals, conductors, and grounding electrodes to safely direct electrical energy into the ground. These systems are powerful tools in the arborist's toolkit. When used correctly, they can extend the life of trees that might otherwise fail. In the next chapter, we'll explore water relations and irrigation, examining how trees absorb, transport, and lose water, and how arborists manage irrigation in urban landscapes. Because supporting trees isn't just about hardware. It's about understanding how trees grow, how they fail, and how skilled arborists can intervene to keep them standing safely for decades to come.
Thanks for listening to the Arborist podcast. Let's keep building your arborist knowledge one domain at a time. If you found this useful, please like and subscribe.